Okay, we've reached question 11, the last question on the paper. This question also deals with probability, so let's not waste any time. Let's read what they tell us. They say that Harry shoots arrows at a target. He has a 50% chance of hitting the bull's eye on each shot. Okay, so let's make a note of that. The probability that he hits a bullseye is 0.5. So that means the probability that he misses the bullseye is also 0.5. Now, folks, note here on your sketchboard that the probability of hitting is 0.5 and the complement of hitting is not hitting the bullseye, and that is also a 0.5. Okay, so let's see what they're asking us. They say calculate the probability that Harry will hit the bullseye in the first shot and in his second shot. So if we translate that in straightforward English, it is for 11.1 the probability of hitting a bull and then another bull, a bullseye and then a bullseye. Now folks, you can draw it in a diagram if you want to. If you want to draw a tree diagram to illustrate the situation for yourself, it would be hitting a bullseye and then hitting another bullseye. The complement of that being not hitting a bullseye, and here we have not hitting a bullseye as well. And then after that hitting a bull or not hitting a bull. So each of these probabilities here is 0.5. So this would simply just be this 0.5 on our tree multiplied by the second 0.5. And that collectively gives us 0.25. It's 0.25 squared. So there's a 25% chance that Harry would hit the bullseye twice in a row. Okay, that was quite an easy starter. Let's look at 11.2 and see what they ask us to do there. They say calculate the probability that Harry will hit the bullseye at least twice in his first 3 shots. There's a lot of information given to us there. So now if we build our tree out even more, he has 3 shots that he is firing. So he either hits another bull, or he hits the complement, or he hits a bull, or he hits the complement. Here he hits the bull or the complement, and here will be a bull or a not bull. And what are we looking for? We're looking for at least twice. So let's mark them with our highlighter. Here he would have hit 3. That would take 3 into consideration. But here there would also be 2 hit and a non-hit. Here there will be a hit on the first, a non-hit and a hit. Then a non-hit, a hit and a hit. And I think that is where we're going to stop. Yes, definitely. So there's 4 of them. There's this situation, there's the second situation, the third and the fourth. And notice that there are also 4 of those that have misfired, where it didn't hit the bullseye. Okay, so for 11.2, our diagram is neatly drawn. It is our tree diagram that represents this situation. So the probability of at least bull, or let's say 2 bulls in 3 shots. Now let's see what the probability tree tells us. 0.5, 0.5, 0.5. And again it comes back to what we've got here in our sketchboard, that these 2 probabilities are the same. Now folks, there's going to be 4 of those. So it's 4 of the 0.5 to the power of 3's. Now if you take your calculator out, you'll see it's 4 times 0.125. And guess what that is? That is 0.5. So there's a 0.5 chance of this happening. Now, if you had used, the alternative will be to use because of the at least, to use the complement. So that would be the one rather, let me get rid of that, the 1 minus the probability where there's 2 or more non-hits. Okay, so we're looking for that situation where there's at least 2 or more non-hits. Now remember here, 1, 1. So it's where the crosses are. A non-hit, a hit, a non-hit. It's over here again. A non-hit, a non-hit, and a hit over there. And here's 3 non-hits. So it's exactly the same thing. It's 1 minus 4 times 0.5 to the power of 3. And you get to exactly the same answer. Whether you used your complement because you read the word at least, that would be your Q. So let me put it here. At least means we're usually going to work with the complement. But in this case, because these probabilities were equal, we could work with any one of the two. We get to exactly the right answer. Now the interesting part is the third part of this question. It says the following. Glenda now has a 50% chance of hitting bullseye on each shot, just like Harry. Okay, what do? Harry and Glenda take turns to shoot an arrow, and the first person that hits the bullseye will be the winner. That's important. What are they asking us? They're asking us to calculate the probability that the person who shoots the first will be the winner of this challenge, who shoots first.